What's up? What's up? It's your man, Jimmy Chan. All right, so today we're talking about normal curve and distribution, right? Some of the properties of it. It's symmetric about its mean, but remember the mean is equal to the median and equal to the mode at this point in time as well. The mean is known to be 0, while the standard deviation is known to be 1. The inflection point occurs at mu minus 1 standard deviation and mu plus 1 standard deviation. What does that mean, inflection point? It means that the concavity changes at that point. So, in other words, if I look at it right here, this point right here is where to the left of it, it's concave up, and to the right of it, it starts to concave down. Okay, so that's what it means by inflection point. So same thing on this side, right? To the left of it is concave down, where to the left of it, to the right of it is concave up. So that is what the inflection point actually means. Okie doke. All right. So the area under the curve is 1, meaning 100%. 1. The number 1, okay? The area under the curve to the left of the mean is 50%. So everything here will be 50%, and the other side would be 50% as well, right? So that would be a 0.5 or 50%. The same to the right. And the empirical rule. The empirical rule says that the area under the curve within 1 standard deviation is 68%, meaning from 1 standard deviation to the left and 1 standard deviation to the right of the mean is a total of 68%, which is, again, symmetrical. So therefore, 1 standard deviation to the left is going to be 34%. 1 standard deviation to the right is also 34%. Okay, so basically taking the 68 and dividing it by 2. All right. Now, 2 standard deviations away, right? The area under this curve, 2 standard deviations away, right? Mu minus 2 standard deviation and mu plus 2 standard deviations is going to cover about 95% of it. I know that these two little parts right here will be 68%, right? So if I take the 95 minus the 68%, and then divide that by 2, I'm going to get that 13.5%, okay? So that's how I would get these two here, right? And that is 2 standard deviations away. And with 3 standard deviations, whoa, that's going to be 99.7% of that, of the population, which covers quite a bit. There's not much left, and if you look at these, look at what's remaining. 0.15% on each side. That means 0.3%, right? So not just 30%. That's not what it's saying. It's 0.3%. So a third of 1% is what's left over. Okay, so that's quite a bit. So same idea here. I just basically did the 99.7 minus the 95%. And then took that and divided by 2. And that's going to give you that 2.35%. And then to get the 0.15, I just took the 100% minus the 99.7 and took that and divided by 2. So that way I got the 0.15%. Okay? So that's how I got those percentages, all right? So those are the things that you need to know, and let's do an example. So this example says, hey, you're given this normal curve, and it's giving you guys all the information except for the mean. So it's saying, hey, what the heck's the mean? Well, that's easy, right? Because this is all symmetrical. So if you notice that these are all separated by 15, right? 130 to 145 is 15. 115 to 130 is 15. 70 to 85 is 15. 55 to 70 is 15. So that means this must be in between these two. So part A, a couple of ways you can do it. You can either do 85 and add 15, right? And then add 15 to that and see if you get to 115. Or you can just take the average of the 85 plus 115 and divide it by 2. And you should get 100. Right? So that means my mean is 100. And if you look at it, if I subtract 15 from 100, I get 85. If I add 15 to 100, I get 115. So that would be my so-called standard deviation. So again, I labeled this in red. So let's put this. This is 15, right? Because I could do it a whole lot of different ways, right? I could subtract 145 130, get 15. 130 to 115 is 15. 115 from, 100 from 115, I get 15. 85 from 100, I get 15. 70 from 85, I get 15. And 55 from 70, I get 15, right? Those are considered my standard deviation. So the question is, what is the probability of or the proportion between 70 and 115, okay? So let's address this separately. I'd rather use more space, but have things clearer in my head. So let me go ahead and duplicate this right here. Glad I was drawing a line that wasn't there. All right, so let me duplicate that right here. Actually, I can do it right here, so that this way I won't waste too much space. All right, so this wants 70 and 115. So if I look at 70 to 115, I'm looking at this right here. Right, this area right there. Is that right? All right, so based on what I wrote way up here, I broke each and every single section down, okay? So what do I have? I have the 34. The 34 was this part right here. It was what, 13.5? Is that right? Let's double check. Yeah, that's 13.5. So now I can just do, okay, so between 70 and 115 is going to be 34 plus 34 plus 13.5, and that's going to equal to, let's make sure my math is right. So it's 68 plus the 13.5, and I get 81.5%. All right, so that's that one. All right, so now let's do the same thing here for this. All right, so let me go ahead and, again, I'm going to move it down here. So what is this asking for? Less than 85%. So it wants everything here. Okay, now you have two ways of doing this. One is to say, okay, I'm gonna one is that you can add up all of these together if you want to, right? Which is, just so I don't get too much here, this was what, 13.5, this was 2.35, and this was 0.15, right? You could add those three together. You could also remember that this right here is, how do I write this? This right here is 50%, right? That whole half is 50%, and this is 34%, right? So that would be 84%. So two ways. So method A, oh, actually, let's go method 1. You can say it's 1 minus 34 minus 50 and get the 16%. Or method 2 would be to say, okay, I'm going to take the 13.5 plus the 2.35 plus the 0.15. Let's see if that does give me 16%. Just for poops and laughs. 3.5 plus 0.15. And look at that. It gives me 16% as well. Right? So there is not really a wrong way of doing it. You just got to figure out which way that it comes to your mind, right? So let me see if I can write this even better. How do I write this even better? So, I did write that in green. The problem is that is in green. So let's do this. Let's write this in. Let's draw this in like, I don't know. Let's do in pink. There we go. So I make this in pink. So we know that this right here right? That right there is 50%. Right? So there we go. That looks weird, but working. All right. Now this says greater than 145%. Okay, let me bring this just down just a little bit, and let's go ahead and copy this again. I'm sure you guys can do that in your notebook too, right? All right, let's do that. Boom. Now this wants to be greater than 145. Okay, so greater than 145 is literally right here. Right? So same thing. I could subtract everything else, but this doesn't even seem like it's worth it because this, I know the answer for this is 0.15. So therefore, I know that this is going to be 0.15%. But yes, you could subtract everything else if you wanted to. All right? So I hope this helps you. If there's any questions, let me know. See ya. Bye.